All right, so let's get going on today's class. So what we're going to do today is we're going to start a extended look at a very important idea for this class for experimental methods in psychology, and that is the idea of complex experimental designs. So far we have only taken a look at the basic experimental design, the post-test only, pre-test, post-test designs. And while that basic design is very helpful answering some questions, there's other questions that psychologists want to ask that cannot be assessed with those particular designs. So we get into the slightly more complex designs that we're going to focus on today. So we're going to take a look at designs that will help us answer questions such as, if you have a treatment that you're designing and it might work for depression, people with depression, and it might work with people with OCD, so it's a new drug, a new pharmacological treatment, and you want to test whether it works on either one of those disorders, you cannot use the simple designs that we looked at before. You would need to use a more complicated, complex experimental design. And we'll take a look at research that has actually been carried out on different learning styles and the ability to learn information. And we'll also take a look at another example that took a look at sexual behavior, specifically predatory behavior, or more specifically, the perception of sexual interest. So that's the kind of general goal. That's what we're going to be looking at. Real psychology questions that use complex designs to answer those interesting questions. So we'll start off with a look at factorial designs. This is actually, as an example, we're taking a look at our study, which is a factorial design. All right, so factorial designs. So a factorial design is used when you design an experiment that has more than one independent variable. So up until now, we've only discussed experiments that have one variable. So for example, in our pre-test, post-test experimental designs, it was TV violence. That was the only thing we were interested in. Does TV violence cause aggressive behavior? But sometimes you want to ask about more than just one variable. So for example, you might, if you're an educational psychologist, want to know what is the effect of tutoring hours and study hours on grades. Not just what's the effect of tutoring hours on grades, or what's the effect of study hours on grades, but what's the effect of both of those together. And importantly, this is the only way that you are going to be able to see if there's an interaction between those two variables. Does tutoring hours magnify or amplify the effect of study hours, for example? That can only be assessed when you have those two variables. You might ask yourself, well, what is the effect of watching sad movies and listening to sad music on depression for men and for women? So these are typical types of questions that psychologists will ask. And the general format for these in a factorial design is that you report or you identify these as the number of levels that you have for your first independent variable multiplied by the number of levels that you have for your second independent variable, multiplied by the number of variables that you have for your third level, multiplied by however many levels you have, however many independent variables you have. So that's the general format when you're reporting a factorial design. So let's take a look at these simple examples first. So let's say that you were doing a study on the effect of tutoring hours and study hours on grades. And for tutoring, you had 3 levels. Half of your subjects. 1/3 of your subjects received 0 tutoring hours. 1/3 of your subjects received 1 hour of tutoring. 1/3 of your subjects received 2 hours of tutoring. That's one variable with 3 levels. You have a second variable, which is the amount of studying that they do One half of your subjects do 0 hours of studying. The other half of your subjects do 1 hour of studying. So let's say that that's the design of the experiment. This design here would be summarized here by saying that we have a 1, 2, 3 levels of tutoring by 2, 1, 2 levels of studying factorial design. And this multiplication here basically is a way of summarizing how many different conditions are in this one experiment. So we got 3 tutoring conditions, we got 2 studying conditions, and a factorial design uses every combination of your conditions to form the entire set of unique conditions. And in this case, we got 3 times 2, we got 6 unique conditions. So we have students that received 0 hours of tutoring and 0 hours of studying. Students that received 0 hours of tutoring and 1 hour of studying. Students that received 1 hour of tutoring and 0 hours of studying. 1 hour of tutoring, 1 hour of studying, 2 hours of tutoring, 0 hours of studying, and then finally 2 hours of tutoring and 1 hour of studying. 6 unique combinations, 3 by 2 factorial design. The other example we suggested here, what is the effect of watching sad movies and listening to sad music on depression for men and for women? In this case, we got 3 variables. We want to know what is the effect of movies, sad versus control. So half of the subjects are shown a sad movie, half of the subjects are shown a control movie. What is the effect of music, sad music or control music? Half of the subjects listen to sad music, half of the subjects listen to a control song. And then what is the effect of gender, male or female? Half of the subjects, let's say, are male, half of the subjects are female. In this case, we have a 2 by 2 by 2 factorial design. So we got 2 levels of movies by 2 levels of music by 2 levels of gender factorial design. So in this case, we have 8 unique combinations. We have males that listen to sad music and watch sad movies. We have males that listen to sad music and watch a control movie. We have males that listen to control music and watch a sad movie. We have males that listen to control music and watch a control movie. We have females that listen to sad music, watch sad movies. Females, sad music, control movies. Females, control music, sad movies. And then finally, females, control music, control movies. 8 unique combinations. And that's very, very quickly communicated by using this format of saying, oh, I have a 2 by 2 by 2 factorial design. So if somebody came up to me and said, oh, I'm designing an experiment, and my experiment is going to be a 2 by 2 by 2 factorial design, I might not know what their experiment's about. I might have no idea what it is that they're investigating, but I immediately know that they have 1, 2, 3 independent variables. They got 2 levels in each. They got 8 unique combinations. So a lot of information can be communicated in that one little phrase. All right, any questions so far on factorial designs? All right. So you can have, in a factorial design, one way to envision it is it's just a continuous multiplication of every single condition that you've had. It's almost like you add another dimension to your experiment every single time you add another variable. So let's say that you have 1 independent variable, and your independent variable has 4 different levels. Right? So let's say that you're studying ages. It's a developmental study. So you have young children, young adults, older adults. You have 4 different levels. You have 4 groups of subjects. That's for a single independent variable experiment. As soon as you add a second variable, as soon as you say, all right, well, I'm studying memory of young children, young adults, older adults, and not only do I want to study memory for words, but I also want to study memory for pictures as well. What you need to do is you need to take every single one of your original conditions and then you multiply it by the second level of your second independent variable. So whereas in this experiment, this group would learn a list of words, learn a list of words, learn a list of words, learn a list of words. You take those same groups and you say, all right, I'm going to multiply it now, but by pictures. So young children learn a list of words, young children learn a list of pictures. Older children, words, older children, pictures. Young adults, words, young adults, pictures. Old adults, words, old adults, pictures. And that gives you now 8 conditions. We've multiplied it by that second dimension. And then you might say, well, I'm also interested in the third variable, time of day. Is your memory better at different times of day? And I'm going to study all of these conditions in the morning, and I'm going to study them in the afternoon, and I'm going to study them in the evening. And now we have 24 unique combinations. So you can see that you always, it can get very complex very quickly, where you can have, we add one more level, we can go up to 80 unique combinations. So usually 3 variables is sort of the limit at which your brain can really wrap its mind around these. But theoretically, there's no reason why you can't have 4, 5, 6, 7 independent variables in your study. All right, so just to kind of give you one last example of this, our study that we did on false memories and group size, that was a factorial design. We had one independent variable that had 3 levels, that was group type. We had a second independent variable that had 2 levels, that was item type. Was it a correct item, or was it a false memory critical item? So we had 6 unique combinations in a 2x3 factorial design. I got a ladybug on top.